Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's get to the closure problems for chapter 7. Some of these problems showed up in some of your check for understandings, possibly in an assessment last week. But it's good. I don't know how much time we could spend going over some of those questions. So here I get a chance to talk about this a little bit. So for the examples, tell whether there is a positive, a negative, or no association. Okay, so remember, if there's a positive association, that means that as your independent variable increases, your dependent variable will increase as well. So as one increases, so does the other. For the negative associations, as one increases, the other goes down. And then for the no association, it doesn't make any sense. There's no way that you could show that one thing affects the other. So the number of inches of rain per hour and the height of water in the reservoir. So if you think of Folsom Lake, which is a dam right there, that's a reservoir. And as the water comes tumbling down, right, comes down the river, and the rain is filling up the river, and there's runoff that goes into the lake's water level goes up. So as it rains more, level of the reservoir will go up as well. So both of them are going up, so that's a positive association. B, the amount of food a person eats and how many pets he or she has. Unless the food that the person is eating is their pets, this has nothing to do with the other. There's no association between your eating habits and your pet ownership. For C, the height of the tree and the amount of nutrients it gets. So the height of the tree, as it gets taller, it also tends to branch out a little bit. And just hold on for 1 second. I just got an inspiration. Alrighty, look at my lovely tree that I made here. So height of the tree, when a tree grows up, it also tends to grow out. And so right now, the nutrients that it's getting nutrients from its roots in the ground. It's also receiving nutrients from sunlight on the leaves, creating photosynthesis. So as the tree grows taller, it's also going to have roots that go deeper into the ground, collecting more nutrients from the ground, and more leaves throughout the tree, throughout the canopy, creating more photosynthesis, bringing in more nutrients as well. So eventually, you get these taller trees, and there are going to be more and more roots, more and more leaves, bringing in more and more nutrients. So there you go. Fantastic visual there to show that this is, as one increases, so does the other. That's a positive association. And then the number of hours spent hiking in the mountains and the amount of water left in your water bottle. This is a critical part here. The amount of water left in your bottle. If this was the amount of water that you drink while hiking, it would be a positive association because you spend more time out there, you're going to need to drink more water, so both of them are increasing. But in this case, you've got one bottle of water, and as you drink it, the water level goes down. So the amount of water left in your bottle is going to decrease over time as you drink it. So that's what makes it a negative association. Here's another one we might recognize. This one was the most common mistake students made in this was when they're trying to figure out the slope ratio, the change in y over the change in x. They went from here to here. And they said, okay, x increased by 2 and y increased by 1. And so they said the slope was 1/2. That's one line. But if you look at the scaling of the y-axis, that actually increases by 5. So the change in y is 5 units, and the change in x is 2 units. So 5 over 2 is the same as 2.5 or 2.5. So my recommendation always is to do this. Identify these ordered pairs. This is 0, 10, right? X is 0, y is 10. This is 2, 15. And at this point, once you see the two ordered pairs for your lattice points, then determine what is the change in y and what is the change in x. Y goes from 10 to 15, so that's 5, and x goes from 0 to 2, so that is 2. Now, This also happens to be your y-intercept. So when we put it all together, this is the rule that applies for that situation. If you want to prove that that rule is the correct rule, just do this. Say, all right, here's another point where we got 420. So I should be able to plug 4 in here, 2.5 times 4, then add 10 to it, and I should get an answer of 20 for y, right? There's your x, there's your y. 2.5 times 4 is 10, and 10 plus 10 is equal to 20. Yes, that's what we got. This must be the rule that applies for this line. All right, got to do these problems. I know people don't like doing fraction busters. Probably the distributive property isn't too much trouble. But I will go ahead and I'll work out this one, and I'll work out this one. I'll do B and C, starting with B. X minus 2 is equal to negative 1/6 x plus 1/3. So let's use 6 as our multiplier, right? Because 3 and 6 have 6 in common. I'm going to multiply this term times 6, this term times 6, this term times 6, and I'm going to multiply this one times 3 times 2. That's a factored version of the number 6. So this becomes 6x's minus 12 equals, cancel out the 6's, leaves you with negative 1x, and cancel out the 3's, which gives you 2 plus 1, or 2 times 1 is 2. So now this equation has been rewritten as this equation, and now I will choose to add 1x to each side to make that 7x's, and I will add 12 to each side to make that 14. And 7 times something equals 14. Well, 14 divided by 7 is 2, so that something must be a 2. Now for this one, let's start by sending in the dive bombers. And this multiplier only applies to what's inside the parentheses. So that's going to be 3x plus 6. And that minus 3 was not affected by distributive property. And then you got 3x minus 2. So when I combine like terms, this becomes 3x plus 3 is equal to 3x minus 2. If you don't recognize already that there's no value for x that could ever make these two expressions equal to each other, you can always take away 3x's from each side, and you're left with 3 is equal to negative 2, which absolutely is not true. So that's the indication that there is no solution for that particular equation. Problem 21 says Ryan and Janelle are driving from different locations to meet at Mammoth Lakes. When they each stop for lunch, they call each other on their cell phones. Ryan had traveled 245 miles in 3.5 hours, and Janelle had driven 260 miles in 4 hours. So to start off, how fast were they driving? Well, if you recall D equals RT, that's the formula for distance, rate, and time. This all has to do with rate of speed. So the time that you travel times your rate of speed will give you the distance that you travel. And then we could take, what do we have here? The time and the distance. If we divide both sides by t, then you take your distance over time gives you your rate of speed, right? Miles per hour or kilometers per minute or whatever the speed might be. In this case, it's miles per hour. So that's what we're going to do. For Ryan, we're going to take 245 divided by 3.5. Use your calculator for this. 245 divided by 3.5 is 70. So he was traveling 70 miles per hour. Janelle was going 260 miles in 4 hours, which is 65 miles per hour. So those are their rates of speed. So now that we've got that piece of information, now let's read the rest of this problem. If Janelle originally started 575 miles from Mammoth Lakes and continues traveling at the same rate of speed, right, 65 miles per hour, how many more hours will it take her to arrive at her destination? Okay, so she has traveled 260 miles. The total distance was 575. So how much does she have remaining? 575 minus 260. No. Yes. Means she still has 315 miles to go. So we're going to write that down for distance. She has 315 miles to travel. She is going to be traveling. Miles. Okay. She is going to be traveling at a constant rate of speed of 65 miles per hour, and it's the time that we are looking for. Now, let's not use an X. Let's use the T. We don't know what this is. So 315 will be equal to 65 times T. So how do I solve for T here? 315 divided by 65. We just use our algebraic reasoning, and that will tell us our time in hours. So what was my number? 315 divided by 65 is 4.8. I'm going to round that to 4.85 hours. Okay. Now, if you just wrote this as your answer, that is totally okay. It turns out if you take this is 8.85, so you got 4 hours, right? That's this part. And then 0.85, if you multiply that times 60, because that's the number of minutes in an hour, times 0.85, you get about 51. So that's about 47 or 47. It's 4 hours and 51 minutes, but most of you probably gave that as your answer, and that's fine. All right, the last problem. Graph a line that goes through points -2, 1 and 4, -2. So that's the line that is in blue right here. So we do the graph, just counting by ones on the X and the Y axis. You get your -2, 1 is located here. Your 4, -2 is located here. What is the slope of the line? Well, the change in Y over the change in X looks like it goes down 2 units or 3 units to go 1, 2, 3, 4, 5, 6. So 3 over 6 is the same as -1 over 2. Does that look right? There's a lattice point. There's, yeah, down 1, 2 to the left, down, or 2 to the right, down 1, 2 to the right, down 1, 2 to the right. So definitely the slope ratio is a negative slope, and it's -1/2 or -5/10 if you want to write your slope in decimal form. It says graph a line that is parallel to this line. Okay, it didn't tell us. It did not tell us where this other line needed to go, so I just kind of slid it up a little bit. This one has a y-intercept of 0. I made this one have a y-intercept of 3. And if it's going to have the same, if it's going to be parallel, it's got to have the same slope ratio. So down 1 to the right, down 1 to the right, or down 3, 6 to the right. So same exact slope ratio for 2 parallel lines. And I believe that concludes our homework for this closure. And we are getting ever closer to completing the chapter. I think our next activity would be a study guide. All right, take care. Bye. Oh, stop it.
Hey, feeling good, like I should.